Here the center of mass and the collision, we are going to relate these two concepts to understand better on center of mass. We already have learned about the collision in the momentum. There are elastic collision, inelastic and perfectly inelastic collisions we have learned. And this concept is related to center of mass. How are we relating it? And mainly we are discussing about the location of center of mass. Will it change? If it changes, how does it change? And what about its velocity of center of mass? And will the center of mass velocity will change or not? All these things we are discussing here. And this circle, I have considered the blue circle as a mass 1. For our easy calculation, I have taken it 1 kilogram, and the mass 2, 2 kilogram, just double. And the velocity of the first mass is to the right, so it is positive. It is 8 meter per second. This is V1, so velocity of the mass 1. And V2, the velocity of mass 2 is minus 2 meter per second because it is moving to the left. So the positive and negative denotes the direction. Now first, here we should know the location of mass 1 is at 0. The location of mass 2 is 20 meters from the origin. So we can write here the location of mass 1 is at 0 because it is at origin, and the location of mass 2 is 20 meter from the origin. So it is the location. And where is the center of mass? Where is the center of mass? So we have a formula to find the center of mass. It is in the x-axis, so center of mass for x-axis is equal to, we know the formula, m1 x1 plus m2 x2 divided by m1 plus m2. Now we substitute the values. We know the mass of the first object is 1 kilogram and the location x1 is 0, plus mass of second object is 2 kilogram and its location is 20 meter away from the origin, divided by the mass of first object and the mass of second object. And this will be 40 divided by 3 meters. This is the center of mass before the two objects starts moving. So we can say at time t equal to 0, center of mass in the x-axis, it is located exactly at this point, 40 divided by 3. So I want to write this value, just we need this value for our later, so I keep it here. So at the beginning t equal to 0 second, before it starts moving, the center of mass, the location of center of mass is in between these two objects, somewhere 40 divided by 3. It is acting 40 divided by 3 will be closer to the more mass region, somewhere here. Okay, now what happens? Now we start the two masses to move. Mass 1 is moving at the speed of 8 meters per second to the right. So in 1 second, it moves 8 meters. So here it moves to 8 meter. Now this ball reached 8 meter from the origin. And what about mass 2? The speed is 2 meter per second to the left. So in 1 second it moves 2 meters. So at the same time it moves, the bigger object moved a 2 meter from 20, which means now it is located at 18 meters, and this object is located 8 meters. Again, I want to find the center of mass. Will it be the same location? Will the center of mass is located at the same point, 40 divided by 3? No, because now the two objects are closer. So the center of mass is moving somewhere. So we are going to find out. How can we find? We have the formula again, the same formula, we already did it. Center of mass after 1 second, m1 x1 plus m2 x2 divided by m1 plus m2. The mass of first object 1, the location now 8 meter from the origin, 8 meters from the origin, 8 plus the mass of second object 2. Where is the location from the origin? Now the second object is located 18 meter, so 18 divided by the mass of first object 1, and here is 2. 1 plus 2 is 3. So 1 times 8 is 8 plus 36 divided by 3. It is 44 divided by 3. So at the beginning, 0 second, the location of center of mass 40 divided by 3, which is here. Now after 1 second, the location is changed. It is at 44 divided by 3. Now if we subtract these two values, we would know the distance it is moved. It is 4 divided by 3 meters. It is moved to the right. It is moved to the right. And it is moved within 1 second. So the speed of center of mass is distance by time. The distance is moved 4 over 3 and the times taken is 1. So the speed of center of mass is 4 divided by 3 to the right. It is moving to the right. And I want to check the speed of center of mass is changing or not. So what I have to do, I have to continue the same experiment for the next following 1 second. Okay, let's see. How does it change? Now, in the following 1 second, another 1 second, that means 2 seconds, it moved, the first object has the speed of 8 meter per second. So in 2 seconds, the distance covered is 8 times 2 is equal to 16 meters from the origin. So now the blue object M2 is closer from the origin. It is reached at this point, which is 16 meters from the origin, 16 meters. And let's see the object M2. It has the speed of 2 meter per second. So after 2 seconds, the distance covered by the mass 2 is speed into time 4 meters. It moved 4 meters from 20. So from 24 meters, which means it reached same 16 meters. So the mass 2 reached 16 meters and mass 1 reached 16 meters at the time of 2 seconds. Again, we want to find the location of center of mass. What do you think the center of mass is located at which point? Exactly, it is at 16 meter because two objects they collide each other at the point 16 meter from the origin, right? You can see from the diagram. So let's check from the formula. Using formula, I want to check if I get same 16 meter. So it is the center of mass formula, m1 x1 plus m2 x2 divided by m1 plus m2. The mass of first object and the location is now 16 from the origin. And mass of second object, the location from the origin is 16 because they collide each other. So the location is the same. And here mass 1, mass 2, the total mass is 3. So here is 16, here is 32 divided by 3. So 48 divided by 3 is equal to 16 meters. So our assumption is correct. Okay, now I want to find now I want to find the distance, the change in distance, which means at time t equal to 0, the center of mass was here 40 divided by 3. At t is equal to 1 second, the center of mass is moved to the right and it is located 44 divided by 3, and in the 2 second now the location is 16 meters. Okay, now I want to subtract 2 second and 1 seconds. So 16 minus 44 over 3, it is 48 minus 44 over 3 is equal to 4 over 3, and it is again to the right. So if you see here 4 over 3 and here 4 over 3, here 4 over 3. So every time 0 seconds, 1 seconds and 2 seconds, the center of mass, the speed of center of mass is 4 over 3, and always it is moving to the same direction at the constant speed or the constant velocity. So the velocity of center of mass is not changing, right? Let's discuss about the collision. Now one object is 1 kilogram, the another object has 2 kilogram. The bigger mass has the lower speed and the smaller mass has the higher speed. As they collide each other, what happens here? 8 meter per second, but it is 1 kilogram. Here is 2 kilogram, but it has 2 meter per second. What is our assumption? So let's see, after collision, in which direction the two masses move and with what velocity, we can check, and using conservation of momentum. So you know the formula of conservation of momentum, m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. In this case, we don't have v1 prime and v2 prime. If we don't know these two factors, we have one a very shortcut method to find the v1 prime and v2 prime value easily. So you can use this shortcut. Here we have a formula. After many mathematical calculations, we have come a conclusion that v1 plus v1 prime is equal to v2 plus v2 prime. Now write the values. The v1 prime is 8 meter per second and v1 prime we don't know x. Or you write the same v1 prime is equal to v2 is negative 2 meter per second plus v2 prime. Now I want to substitute v1 prime, so I take this as a subject and I change the 8 meter per second in the other side. I want to shift it, so 2 minus 2 plus v2 prime, and sign changes, so v1 prime is equal to v2 prime minus 10. So we can keep this value for later substitution. Now we can substitute the value in the conservation of momentum here. So m1 is 1 kilogram, v1 initial speed of the first object, plus m2 is 2 kilogram and initial speed of second object. And very careful to put the, don't forget to put the negative sign because it is the left side velocity. And mass 1 kilogram, and v1 prime right as it is, plus mass of second object 2 kilogram and v2 prime right as it is. Now v1 prime is equal to v2 prime negative 10 as we found here. We substitute into this equation. So 1 times 8 is 8 plus negative 4 is equal to 1 times v1 prime. So in the place of v1 prime, I want to substitute this 1 times v2 prime negative 10 plus 2 times v2 prime. So if you simplify, you will get 4. You multiply this, you get the same value, v2 prime negative 10 plus 2 v2 prime. Now we simplify this 2. So here 1, here is 2, so which means 3 v2 prime negative 10, and switch the equation so that it will be easier to find the answer. So negative 10 will be positive 10. So 3 v2 prime is equal to 14. So v2 prime is equal to 14 over 3. So v2 prime is 14 over 3 meter per second. Now I want to find v1 prime, so I substitute this value here. So v1 prime is equal to v2 prime minus 10. So v2 prime value is 14 over 3 minus 10. So 14 minus 30 over 3. So which is negative 16 over 3 meter per second. So negative, which means it is moving to the left. So the object 1 kilogram is moving to the left and the object 2 kilogram is moving to the right with a speed of 14 over 3 meter per second, and here negative 16 over 3 meter per second. The calculations are not sure because I am not using the calculator. So this is the concept. To check if there is any doubt, you can post your comment in the comment box. And then now we have found the velocities after the collision. We found it is not stick together. So there are two possibilities. One is elastic collision or inelastic. So how we can confirm? You have to find the kinetic energy before collision and kinetic energy after collision. We have to find for both objects, which means kinetic energy of first half mv square, kinetic energy of second object before collision, then kinetic energy of the first object after collision plus kinetic energy of the second object after collision. So you add right and left side. If both sides are equal, then it is elastic. If it is not equal, inelastic. Inelastic means some of the energy is lost in the form of heat and sound due to friction between the two objects. So these are all the main concept in collision and center of mass. The location of center of mass changes, and it is changes equally every second. It is moving to the right with the same velocity, at the constant velocity during its motion. Okay, thank you very much.